Sorry for rushing things a little bit, but last night during the gala dinner, Charlotte had this fantastic idea, and we really want to test it out and see, can you really do sign language with a suit? Now, all of us have a bit of sign language experience from diving or military or analog missions, but now we want to try and do it with actual sign language interpreters who only signed up for a whole conference. They didn't know it was about space until 2 weeks ago, and now they even have to wear spacesuits. So I think you need a pay raise, but we'll see about that if you deserve it. So good luck.
Yeah, we agree on that. Definitely agree.
Can you hear me? Does the mic work? Okay, perfect. So we're going to ask a few questions. Then Tom is going to sign that. And basically, he's going to respond in the suit, and then we basically have a both conversation. So the first question that we're going to ask him is, what is an analog astronaut?
Analog astronaut. So an analog astronaut is a person that wants to go into space, but first they do the practice and they do the research, they do their experiments here on Earth in a habitat. And then it will be as a simulation that will then allow the people to learn, to experiment, to do their research here on Earth.
Okay, perfect. Thank you for that answer. Wow.
Thank you.
Okay, we're going to ask 2 more questions, and then we're going to talk a little bit about the problems that they are facing. So the next question is what is CHASM? Can you explain to us what CHASM is?
So, CHASM, C-H-A-S-M, that is a group or an organization of people from different countries throughout the world that come here to talk about analog space missions. And they also try and share information, network, share different ideas between everybody that's here. The research that goes ahead, the presentations, and really just sort of create a bit of a community.
Okay, perfect. This is going so much better.
And also, well done to the interpreter for the receptive skills.
Yeah. Okay, and then the last question is, can you tell a little bit more about how you would see sign language to being implemented in spacesuits?
So do you mean from like the hearing people would use, or do you mean as the deaf community if there was to be a deaf astronaut?
So indeed, one deaf astronaut, but then how would they clearly communicate during a spacewalk?
Yes, so if there were 2 people, for example, that could sign together through a shared language, i.e. myself and Tom, then really it could be used for anything, in any sort of aspect of it, through a spacewalk. It could be through, we have a problem with X or Y or Z. How do we fix that? How do we go through that? And then we need these tools, that tool, what have you. And then, I don't know how I'm doing this. It could be sort of taught on the job sort of thing. So yes, that communication would be really useful to allow the mission to sort of run smoothly.
Okay.
So an issue that we have though, it's difficult because the fingers, the dexterity of the gloves is really, really stiff. The size of the bubble that is really difficult for using signs that are placed on and around the face. The heat that I'm experiencing from obviously moving, it is hard work.
So can you imagine doing this for an 8-hour EVA?
8-hour EVA. As the answer that we're saying to that, no.
So basically...
Yes, definitely that we taught you last night, worn out like that, yes.
Okay, perfect. So big round of applause. So we've already been discussing for the last 30 minutes about incredible research ideas, especially with Leszek and maybe Lunaris, maybe the OWF, maybe some other parties. It would be really nice to start thinking about this, especially in terms of inclusivity, diversity, and especially with ESA para-astronauts, to really see where we can push this further. Because I've just experienced so many upgrades to be made to the spacesuits, or to the simulated analog spacesuit. And this is just one suit. There are many analog suits out there. So what would be the most ideal combination for them to clearly communicate with each other? And can we use, for example, a heads-up display or other tools? I will talk a little bit more about that during my talk.
Thank you. Thank you.
Okay. Big round of applause, guys. Thank you.
So thank you very much. Do you need to help him out of the suit?
Yes.
Okay. So while you do that, I'll prepare your presentation. So we're going to segue into ICEE.space presentation. So thanks to this little demonstration, this fantastic demonstration and feat of strength, honestly, because we all know how uncomfortable spacesuits can be. Well, most of us, but I think everyone had the chance of playing around in a spacesuit, if not doing a mission anyway. I think it's really bravo, but those suits are actually going to be used for chill ice missions. So it's actually really good timing. Let me see. It doesn't want to. Does it want to? Yes. Fantastic. Okay. So the floor is yours. Hey, thank you.
Okay. So first of all, good afternoon, everybody. I must say I'm so excited to be here at CHASM. And from all the CHASM conferences that I've been so far, this has been the most astonishing that I've been. So big congrats to the whole team on that. So I'm going to tell you a little bit more about ICEE.space, who we are, what we do, our latest missions with Chill Ice, but also some exciting news and some new upgrades that we have made. So a little bit about me, and I will just keep it short. I'm from origin a physicist. Then I went into radiation research. I switched to plasma thrusters in Australia. Then basically went to work as a test engineer for Airbus. Moved to the Galileo program, working on launch and space segment, decommissioning of satellites. So basically everything from TRL 1, so proof of concept, all the way to TRL 9, like flight proven, is something on my palette. In addition, I work for ESA Champion, which is like a small program to do public speaking and promote space on a global level and to promote ESA and see what we can do further. And as my hobbies, I like riding my motorcycle and basically doing any extreme sports, I think, as most of the people who are here today like to do. So as mentioned before, I will talk a little bit about who we are, what we do. The Chill Ice missions, which is what is happening in Iceland most of the time. Our new habitat that we designed for the last 2 years. Thank God COVID also had some benefits to really dive deep into it. And developing a new suit. You're seeing it here today, one of the demos that we're using. This is only the outer layer. None of the technology is actually integrated in it. So that is something that we will talk a little bit more about as well. Then, one of the most exciting things that I've been working on for the last 2 years with the team is the Analogue astronaut kit. And what that entails, I will come to that. And also our Analogue mission offers. And of course, our future planning for the next year, 2 years. So why Analogue missions? And especially for us, we're mainly focusing on the moon. And it's because you all know we're going back there. And at least there are 400 lunar missions scheduled, both robotic, satellite missions, human exploration missions. So a lot of exciting things are going to happen in the next decade. But we need to better prepare for that. And as you all know, we can use analogs for that. So ICEE.space is an international company. We're focused in Czech Republic. We are incubated with ESA BIC. But we also have a location in the Netherlands, and that is because most of our team is actually from the Netherlands, as myself. So we basically provide analog testbed simulations in extreme environments on a global level, so not just in Iceland. So how do we do that? We focus mainly on research with TRL 3 to TRL 7, so basically helping researchers, manufacturers, industry, space agencies to focus on a proof of concept and actually get it ready to an operational environment. And we do that basically allowing us to give flexibility to the missions and doing it for a very low cost. Because I've been running 4 missions now And every time the cost keeps increasing. At some point, CHASM, I think, is coming to 100,000 euros just for one mission. That is a lot of money. So we're really trying to see how we can make it more efficient, but also reduce the cost, and at the same time increase the quality of the research and the systems and the infrastructure. Okay, so a little bit more about the ICEE.space team. I'm the CTO and one of the co-founders. Then we have Mark Heemskerk, for who you guys know, just recently moved from Norway to Estonia. He's going to do a PhD there as well. And he's our CEO. Then recently, since last week, we actually upgraded the team management with a new COO, and that is Niels. Niels was our system engineer for already 4 years. He has a lot of experience on the IT department, on making sure our systems are secure and safe to work with, but also actually building the systems. So who better to join our operational lead management than him? And as you can see, we have people from all over the world. There are actually 2 new members that have joined, but I didn't get their picture yet in time, so but they will be added here too. And that being said, we are really a global organization. So this is currently what we're aiming for. Everything that is red is something we've already completed. Everything that is gray is on the list for the next 2 years. So you can see it's really expanding. So for 2025, we're aiming a mission in India, we're aiming a mission in Mongolia, we're aiming a mission in Australia, hopefully with the world's biggest Analogue, and the ICEE, of course. We did some work in Chile, and we basically collaborate with people all over the world. There's only 1 continent or 2 continents that we haven't been to and want to add to the list, and that's Africa and Antarctica. So if you have any ideas or suggestions for that, I would be happy to hear about it. So giving in short, it means we have 1 mission coming up in Iceland in 2025, which is a CHASM-3 mission. It was supposed to happen this year, but unfortunately we had some struggles with the land, so we decided to postpone as well to better prepare for it. And one of our Analogue astronauts who went through the selection, Olivia, is also here with us today, and she will later on as well give a demonstration. So we have 4 successful missions. We've reached over 2,000 people in STEM education because ICEE.space is focusing on the analogues, but we're also working with universities and educational platforms to really bring forward more communication towards high schools, universities, or even elderly homes to talk about space and let them learn about different elements such as satellites, launchers, or even space exploration missions. So being short, we have the CHASM-1 mission. This one happened in 2021. It was our first mission that we originally also collaborated with EuroMoon Mars on this project. It was a 3-day lunar analog simulation. And with CHASM, it is quite interesting because we're doing something that hasn't really been done before. We come in, we find a lava tube, we deploy our whole system inside the lava tube, and we let the analog astronauts stay there for a short amount of time. But finding a lava tube where you can actually set up a habitat, that is quite challenging. Because I'm not sure if some of you already have visited some lava tubes, but these basically these big rock formations that also are able to collapse, and there are some risks with the rocks. So our risk assessment is going all over the place. But it's a very interesting possibility to do research about lunar lava tubes. I'm not sure if you guys all know, but there are lava tubes on the moon. At least that's what we predict based on the satellite imagery that we're seeing. And actually, when we're going back to the moon, it would be very interesting to deploy some of the rovers first and to actually scout these lava tubes. Because these lava tubes would be ideal. And why would they be ideal? Mainly because they offer the opportunity to really get to know more about space, where do we come from, the origin of life, because some of the elements that are there are preserved against the harsh space environment. In addition, it offers a natural shield against cosmic radiation, against the galactic cosmic rays, the solar energetic particles, solar flares, micrometeorite protection. So you just have this natural dome that is already shielding you, which would save an insane amount of costs as well. And with that, we're looking mainly at inflatable technology. So I love what CHASM is doing, especially for the space habitats that they're building already. But using that same technology and then actually deploy it on the moon would save cost for the launch, it would save mass, and therefore it's the cost, but also allow for way more space at the same time. So with moving that forward, I think I'm tiring the guys. A little bit of an overview of CHASM. It depends on the mission, but we basically on average have about 16 countries that are involved, which means a lot of logistical nightmares and a lot of logistical coordination. But luckily we have a very, very dedicated team for that. This also means, as you can see, this harsh environment, that they have to go in themselves. They use climbing gear, they use additional protection, shielding for their knees, and they basically do an 8-hour EVA. And this 8-hour EVA is a simulation of how much time they would have on oxygen, but also to complete the whole system setup. So they basically go in and set up most of the equipment themselves, set up the habitat, set up the communication system, set up the power system. We just provide only the deployment, and they do everything themselves. Which is a very hard challenge, as you could see how much they were sweating already after 5 minutes of using sign language. And ergonomic is also an issue. So one of our partners created a 3D scan of the lava tube in Iceland that we're operating in. It's called Surts Hellier and Steffens Hellier. They're 2 different lava flows, but they're absolutely gorgeous. And I just want to show you a brief LiDAR scan and drone footage of this lava tube. So this is the top view before you enter. And then when you enter the lava field, you enter via a skylight. And these skylights are basically large openings based on a collapse. When the lava flow was being cooled down, it basically collapsed in. And you see how many rocks there are there. The lava fields are protected. You're not allowed to move any of the rocks. So when you're moving in your heavy equipment, you basically have to be very careful to not damage any of the environment and also still stay safe yourself while you carry everything inwards. And we're showing you the Steffens Hellier lava tube system, and that's mainly because the Surts Hellier lava tube system we tried to shield from our Analogue astronauts, so they do not know how the lava tube looks like from the inside before they start the mission, as they would not know that on the moon as well. Okay. So then in terms of safety, we enter the lava tube via skylight 1. This is also our assembly and safe area. The rescue team or our first aid team is also positioned there. They basically camp out in 4 degrees weather, heavy rain, heavy winds. Icelandic is very subject to very heavy winds. And they're basically trying to survive themselves while they're also being on standby in case something happens to the Analogue astronauts. They are also in contact with the Icelandic rescue team who come in with a helicopter in case anything happens. But still, in case there is anything that requires some medical attention within the first hour or so, because it takes about an hour for the helicopter to get there, they would have to be able to intervene on site. Then it takes about an average from the entry point to the habitat about 10 minutes. We have our CEO and field geologist who is very, very experienced. He did a record in 4 minutes. Do not try that at home, please. It's very unsafe, but it is able to do it on a faster pace. And you can also see the position of the habitat. So in previous missions, CHASM 1 and CHASM 2, we had 1 inflatable module. For CHASM 3, we have 2 inflatable modules. And this is an example of the team of last year who came on site. There are about 20 to 25 people. The Analogue astronauts of that year are in gray. And I think some of the Americans here, they can maybe recognize one of the faces. I see a lovely bald head there. So, yes. So Cody, who they might know, was one of our Analogue astronauts who came through the selection. Also an example of how our flight schedule looks like for just one day. This is just one day. Of course, we removed all the details about the persons, so this can be subject to just one person. Then we have a flight schedule for MCC, a flight schedule for the first A team, a flight schedule for each Analogue astronauts, and we have a flight schedule for the researchers who are also involved, because they need to know exactly what to do when, and when we need them, and when they need to be on standby. So it's a very logistical, organizational nightmare, but luckily we have very dedicated flight directors and support in that, who have a lot of experience based on their industry and their governmental experience on that. Because there is so much research going on, and there are many publications there about as well, I just want to briefly highlight one of my personal researches that I also concluded my master thesis in, which is designing and developing a heads-up display for analog spacesuits. And as you all have maybe seen the spacewalk that happened on Friday with SpaceX, with the Polaris Dawn mission, I was very, very excited to see already a heads-up display being integrated. Unfortunately, in the dark, this is a big problem. And we will also brief upon that, how we made some modifications with the suit. So first of all, the heads-up display needs to be integrated in the helmet. Then second, you need to be able to comply with the power. Then you need to make sure that the communication is stable. And there are many other features in terms of headaches or forces that are acting on your head. So the Analogue astronauts, they would go around the lava tube. This is, by the way, a picture taken from MCC. So we could see in real time what they are seeing. And the Analogue astronaut was able to place a waypoint, for example, a geology site that would be of interest. And it could come back later to actually navigate to it and find some of the rock collections that are there. Then in terms of communication, because we could see what they are seeing, but they, of course, cannot see what we are seeing. We had voice communications, but we're looking as well at visual communications. So who here can see what we tried to write to them? It's very, very difficult, especially with the screen right now, but if you look very closely, you can see "Hi, MCC." And the reason why it is so difficult is because of the instability in the communication and in the connection. It basically disrupts the signal, and that creates a dot instead of a line. So that is something that has to be upgraded. This, by the way, is a research from the NASA suits Texas A&M University that we are developing then at the time. And they're continuing the work each year to better develop a heads-up display. So some of the research papers that we presented, because we have the PIs, that mainly are the owners of the research, we only provide really an overview of the mission itself and the research that we are conducting on a personal or on our research level, on our company level. But there are many researches being done that you can read upon if you just Google for CHASM or ICEE.space or any of that. So then, in terms of CHASM 3, we basically had a break for 2 years to redevelop a new habitat, redevelop new suits, and redevelop basically everything that we are doing as an Analogue astronaut mission provider. So we went back to Maslow's hierarchy of needs and basically looked at all the feedback that we got from the Analogue astronauts and from our MCC team and really went into the basics from, okay, how can we improve the physiological needs? How can we improve the safety needs? And we went all the way to the top. And this way we can guarantee that the people who are doing the mission actually feel safe and they have the trust in the team and in the research to become the best version of themselves to properly execute the mission. And of course, we don't do this by ourselves. So this is an overview of our company organization and the CHASM department. You can see that CHASM is almost as big as the whole ICEE.space team. And there are many, many different divisions in that. So focusing on CHASM, you can see our head of Analogue astronauts, Eleanor Poli, who is here as well. You can see Olivia, who is one of the Analogue astronauts and is currently acting as Capcom. And the research team, the medical rescue and safety team, mission support, and external relationships. Okay. Our selection process. For chill ice, we tried to implement a similar strategy as the OEWF by following the ESA and the NASA selection process. So we were very fortunate with having Eleanor on site with us as well. It consists out of multiple phases. So we do a thorough screening from all the hundreds of applications that we go through. And one of the most important factors is that we exclude ourselves from the interviews if we know that person. And that is basically to try to stay as unbiased as we can. The only problem is that when the very high qualified people, and we know a lot of high qualified people, go into the last stage, we do have to be involved at that point. So our solution to that is to also invite an external jury. So each time we do a mission, we invite experts on specific matters. And one of those experts is Elettra Polly, who is a medical doctor. Other is Christoph. I cannot pronounce the name, Momata. And Charles Sam Gamar, who is a NASA space shuttle astronaut that I work with on a frequent basis, who is an insane, inspirational person who travels all over the world to inspire the next generation. And of course, we're trying to implement as best as we can the international guidelines and standards for space analogues that has been recently developed, and the first version has been shared with the community. So, the new habitat. So I would like to introduce to you the Extreme Cave Habitat 1, which is the first inflatable pressurized module that can go subsurface up to 160 meters underground and can be deployed in less than 2 hours, which has been a huge milestone, reducing the time from 8 hours to 2 hours. In that regard, we did not do this only by ourselves, because unfortunately we don't have a factory. We don't have the manufacturing expertise on inflatables. So we're partnering up with Michelin Inflatable Solutions. They're located in Paris and have been an incredible support in looking at our designs, looking at our material selection, providing us with the expertise, and then actually constructing this habitat. And I can tell you, inflatables and rocks, they do not combine very well. Especially when there is one small puncture and you have a leakage. We have experienced that during the previous 2 missions. It can be detrimental to the mission success. Also, in terms of safety, we included a few redundancies. So we have an exit in case of emergency on the outer side. It is a modular design, which means that you basically can keep connecting modules. You can keep connecting inflatables, and you can keep connecting airlocks. The HVAC system, the humidity, ventilation, and air system, is located in the center near the airlock. And then you have the main entrance as well of the airlock. So you could connect another airlock to each side and keep expanding. The airlocks are flexible, which means that you can rotate it up to a 30-degree angle, which also allows for the flexibility if you need to go around a corner or maybe at some point want to make like half a circle. We basically went for this approach because we're working in a lava tube, and the lava tube is basically straight. These 2 modules together are about 16 meters long, which means I think they will not even fit in this space. So it's a very large setup, which allowed us to give more space to the crew as well. This is a picture of the team of Michelin when we visited them. You can see one of the inner structure beams as well behind us. And it might not look that big. I'm 1.65 meters, but it's about 3 meters in height. So if I stand like this and I jump, I cannot reach the top. Some more of the pictures. This is the deployment test at Michelin. And because this is an inflatable structure, it also has an airtight bladder. And this is something that we were really, really focusing on to actually make a pressurized habitat. Of course, we also had to do stress testing. So we did some modeling first together with Michelin to make sure that it can survive the stresses on it, and also to see if it could survive any rocks that would fall down, so that if you're sleeping quite comfortably, you feel very safe, and a rock would fall down from the lava tube ceiling, you would not get it on your head, which is a big safety factor. So in short, the Echo Habitat is available for pressurization. It has a control system. Unfortunately, it's not completely closed loop yet. We're trying to fix that as we speak. It has an anti-leakage separation module system, which means that each beam can be separated. So if there is a leakage in one beam, we can completely isolate it and make sure that we fix that, repair that before it affects any of the other beams. So there are more redundancies in place. And an additional factor that we're looking into, that we have implemented in the habitat, is to add circadian rhythm lights. And that's mainly because the Analogue astronauts are in complete darkness. They only have the light of the habitat. So they do not know when it's 6 a.m. or when it's 6 p.m. And they're not allowed to go outside. So for CHASM 3, that means that they will not see any daylight for 14 days, simulating a lunar night survival. Moving forward to the sensors that we put in place. So basically, the system measures the temperature, humidity. Humidity is a very important factor for us because the lava tubes have often 90% to 100% of humidity, which allows basically for a whole pool to enter your habitat. Especially during CHASM 1, you could almost shower within the floor. It was a big lesson learned on that. CO2 removal, you want to make sure that they stay as safe as they can. We measure air quality, we measure dangerous gases in the cave as well, the pressurization and the particles. And we can also adapt, add any other sensors of things that people would like to measure. And you can see one of the installation layers as well wrapped up, which basically makes sure that we can have a nice, comfortable temperature of 20 degrees. Just in short, this is how our system architecture looks like for the habitat alone. And every segment is a lot of work to really complete and make sure that everything works. So if I've not been responding to emails very much, I'm super sorry, but this definitely takes some of your time. Then I would like to move forward to the suits. Olivia, are you ready? So for the suit as well, because we don't have a factory and because we're not a main manufacturer, we're working together with Smith's Suit Garments. And you probably have already seen some of Smith's work. It's very impressive, especially for the underwater suits that he is making. And he has a lot of experience as well with high altitudes. So we basically use the outer layer of Smith, and then we basically implement all our own technology into it. So for today, I've only brought the outer layer from Smith Garments with me because the other technology is more IP protected as well. And I will give Olivia just a second to get dressed into it. So for my background and for my master thesis and research on my master's, I was really focusing on spacesuit design, and I've really continued that work, mostly focusing on adding innovation technologies into it. So it's just heads-up displays, but also increasing mobility, making sure that it is usable in a dangerous environment or extreme environments, such as lava tubes and caves. But also that... you good? Perfect. But also that communication will become easier and easier. And I was very, very impressed with these two guys, how they were communicating with each other and how we can modify the suits to also be inclusive with the future generation of astronauts who might need to use sign language. So in previous designs and previous work, I've worked with the burp suit before. CHASM 1 uses the Astroland Agency simulated suits. CHASM 2 used the burp suits, and we just kept improving, we kept learning. And Paul Bakken is an amazing support with this to keep working themselves. I've worked with ICEE already in 2019 when I was doing the Analogue astronaut missions, and the work that OEWF has been doing with the suits is also really been fascinated. Especially in looking as well for females, the smaller females, and also making a suit that is adjustable in size in terms of arm length and waist. Those are some of the modifications that need to be made. Because whenever I was wearing one of those suits, I never could see my toes. And whenever I could see my toes, I would need to lean forward. And almost when I was leaning forward with the weight of the helmet and the weight of the backpack, I would just tiptoe forward. And if you do that in a lava field, yeah, it's going to cause for some dangers that you do not want to have. Okay. So some of the targets for the next suit that we are addressing is to act as a demonstrator for analog missions. So not only for ICEE.space, the suit is accessible to all. In case you need a suit to test some new research, if you wanted to test it at your lab, you want to test it in other analog missions, the suit is available to all, basically. One of the major importance is that, Olivia, can you come to the stage, if you can hear me? I'll just correct the helmet. In your hand? Perfect. Okay, so it's not completely sealed off. Can you hold it? Okay, perfect. So we want to test the suit and the new innovations that we added to it, at least for 100 EVAs. So the goal is with this suit, when all the technologies are integrated in it, the new comm system, is that it can survive at least 100 EVAs, or simulated EVAs. And of course, that is being tested in different environments. So I want to test it in a closed environment. We want to test it in a Martian similar environment, such as a desert. We want to test it in the caves, which one we use CHASM for, and basically keep expanding. If we can test it in Antarctica, even better. We also tested it in the glaciers of Iceland, and it worked quite well. Right now, the power system, ventilation system, communication systems are all not connected, but on the comms, this is one of the most major improvements that we made. As I ride a motorcycle myself, I know how important it is to have clear communications, especially during your EVAs. So we're working now with the Blue Mesh network, and we basically use spin-in technology, so using an existing product, make our modifications and adaptations, and then implement that within our suits. That leads that our suits and our communication system can support up to 160 meters underground, as far that we have tested right now. And in line of sight, 800 meters, while staying in direct communication link with MCC at the same time. And MCC can be located in Japan, in Antarctica, Australia, it doesn't matter. So especially for the world's biggest analog, this could be very interesting to also include in the suits. Right now, she doesn't have a communication system, but we tested it in Iceland with 100% humidity while implementing the coding and the ventilation system, and there was no fog. And while I've been working for 5 years with suits, I've always had the difficulties with the amount of fog that was here in the front of my visor. And this was the first time it was not a problem. And they were walking around doing heavy exercises. It was clear vision. We did notice that the ventilations, of course, make a lot of noise. But luckily, our communication, we could improve the noise canceling, so you can cancel out the ventilation sound. So for MCC, it's not a problem with the comms. For the analog astronauts, we might need to add earplugs. That's another point. This is an example of how our communication system right now works in terms of line of sight and in terms of communication. We use internet, we use direct, and as a backup, we also have a walkie-talkie. This means that the first A team can at all time listen in to the analog astronauts while they're in the habitat and while they're doing an EVA. So in case anything happens, within 10 minutes, they can be on site to help. Also, all the analog astronauts get a medical training, so they know how to get themselves out of the suits, they know how to basically help each other, and know how the communication system and everything, of course, works. Big applause for Olivia. Thank you so much. Then something new, something exciting that we've been working on as well for the last 2 years. Because there's so much exciting research out there, and we get contacted by researchers from all over the world who unfortunately lack budget to travel to Iceland or to travel anywhere where the mission is being conducted. And as well, most of the missions, because it is a very complicated sector with budgeting and funds, it's also a lack of budget often to participate in the analog missions. So we're like, how can we improve that? Well, facilitate and offer people the chance from all over the world, even from emerging space countries, to perform their research or perform some sort of an analog mission or explore. We developed with that the Analogue astronaut kit. So the Analogue astronaut kit basically stands on its own. You basically can tell us what mission you want to do, where you want to do it, how long you want to do it. We basically provide the whole MCC infrastructure. You can add your own sensors. You can add it to our VPN-secured cloud software system. And we will also be on standby in case you're experiencing any troubles. We have a remote power system that works on solar panels, but also on generators. Or if you have your own power system, you can connect to it. We have cameras that can work in the dark. So basically, it's a plug-and-play solution. So it's only the shipment time that is your waiting time. And of course, you designing the mission for yourself. We can also advise or help you create a mission and tell you about some of the research that is currently lacking. Right now, the Analogue astronaut kit is mainly focused on researchers, but we're also looking into providing it as an educational platform for universities or high schools who just want to do a one-day experience, let their students come in, tell a little bit more about how an Analogue works, and that they can see with their hands-on experience how it works and what you can learn from it. That being said, in summary, we are providing an Analogue mission offer. So it can be hardware, we can provide the software, or we can provide the expertise, basically providing the trainings, the different experiments, different mission scenarios. We can help with the crew training. We have basically different experience on that as well. The spacesuits, or the simulated spacesuits, the habitats, communication system, if you need help with that, it's all in place. So for a 7-day mission, for example, or for a 5-day mission, this is approximately how a 5-day mission would look like. So you will have one day that you will really focus on the Analogue crew training. If it is an Analogue mission that you're planning to do, for example, like FMARS in Devon Island or in a desert somewhere, we also have geologists that can provide geology crew training to really make sure that they know and get the best out of their simulated EVAs and what to look for, what the key indicators are. And then basically you have the 5 days. Normally we do our simulated EVAs from 2 hours to 8 hours, but it can depend, of course, on your needs. If you need something else, we can adapt. This is just a standard template that we use as a guideline. Then in terms of cost, because that's always a big factor. Like I told you guys, when doing these Chill Ice missions, I always find a very hard time to find budget, to find a research grant, or to find something to actually do these missions. And we always had to rely on sponsors, partners, which really also took away some of our independency on that end. So we were trying to see how can we help the sector, how can we help the community by really being in control of their mission, and only needed a small amount of funding to succeed in what they were trying to achieve. The first Chill Ice mission costed for us around 20,000, 30,000. The second Chill Ice mission for us was around 50,000. Chill Ice 3 will go to above 100,000. So how can we make it more beneficial for the sector? We basically divided a cost breakdown for a rental 5-mission system that we can rent out the whole Analogue mission infrastructure to you, as well as 2 experts for just 14,000 euros. And this is a first tryout that we're doing. So this is only going to be for 2024, 2025 at the moment. And then we're going to look into the feasibility and as well further improve. And just to mention on that, ICEE.space is focusing all its resources, all its revenue back into the systems and back into the people. So that means that all the costs that we make with this tryout for the next 2 years is going back into providing for our MCC, so that when MCC is coming to Chill Ice of one of our other missions, that their logistical costs and on-site costs are taken care of. Because I know for myself, it's a pretty pain in the ass if you constantly have to move all over the world and have to pay for that yourself. In that regard, the only problem is, I think, the shipment. For Iceland, it's about 2,000 euros for our container. So it really depends on how much you need and where you want it to be set up. Okay. Then in terms of future, I already showed you some of the missions that we're heading towards. So we just completed our Chill Ice field test. We're attending the ICEE in Milan. And together with ICEE.space and the embassy there, we are organizing on Wednesday evening from 6 to 9 p.m. a cocktail party, where at 7 p.m. we will start an ICEE.space spacewalk fashion show, which means that for 30 minutes you will see from us and our partners. So anyone here as well who wants to showcase something, we're open for you to also demonstrate that. We have governmental agencies who are coming, industry who's coming, Analogue astronauts who are coming, basically all people from all over the world. If you're interested in attending that event, unfortunately, they only have a maximum amount of people of about 200-300. So we have a list. So you would have to contact me directly and to ask if you can be added to the list. But I would be very happy to see all of you there. Then furthermore, our team is going to Thailand and Malaysia to do some more educational programs that we're running there together with our partners. And in December, we're starting a new round of master thesis students. We're currently accepting new master thesis students as well on different aspects, so habitat, suits, biometrical sensor readout, heads-up displays, communication system, basically anything that you can think of, we might have a master thesis position for that. And then in April, May, we're going to Saudi Arabia and Mongolia to do missions there. This is also when we will complete our ICEE.space. And then we're moving in June, July towards castles together with ICEE.space and preparations for Chill Ice. And then in August, we have Chill Ice 3. And then in September, October, Australia. And I'm very happy to go back to Australia on that end. And I think that is it in short. I think we have a bit of time left. So I want to thank you for your time. And if you have any questions, let me know.
Thank you so much, Charlotte. And yes, it's so exciting to see those lava tubes, even the really, really tiny ones where we went this summer. But
Yeah.
it's such a fantastic endeavor and perfect for moon simulation. Go ahead.
Hello. Hi.
Hi.
I have a very nice presentation. Thank you for it. And I have one question. Like you mentioned that as a part of your future plan, like you are expanding globally, like to also to India and Antarctica in the future as well.
I hope Antarctica. I hope.
Oh, okay. Okay, but India is in the near-term goal, right?
Yes.
Okay.
Yeah.
So have you identified a region where you can build a habitat, like in Ladakh? Because people say that's one of the most suited for a analog mission. So is there some plan there? Like, do you have few identified regions where you want to build a habitat?
Yeah, so our geologists in our team, we have two. They are looking at the locations. And once we have identified the locations for our missions ourselves, we go to the government and we basically ask them, okay, we want to do a mission here, 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 or here. Can you tell us where it is acceptable and where you can support us with logistics? As OUWF also mentioned out, you really need to have the local support to get things done. Because otherwise it's almost impossible to get things. Even if I need to find gasoline or if I need to find a generator and I don't know where to go or I don't have a local citizen card to actually rent a generator, it will already disrupt the mission. So you really need to work with the local parties. So if you have any recommendations yourself, we will be open to
Sure.
to hear.
I mean, I had discussions with the government teams before, so I could help you with some contacts.
Perfect.
Yeah. Okay.
Great.
Thank you.
Yeah, so congratulations. It's a great mix of creativity, the smart part, and organization, getting the things done, the team spirit. And so it's very great to see after your moon mass how you have really developed and on your own, also with entrepreneurship, with some of the support from ESA incubation program. So that could be a great model also for others that develop some services for analog astronaut. I have a question now for a campaign, for instance, in Australia. So you would build a transportable habitat, or so what class of habitat are you thinking of, and is it something you will bring along in the campaign, or something that would become a kind of infrastructure that you leave in the different partner sites?
So right now our system is plug and play. So the only thing that you would need is a location and an MCC location. So MCC could be in the Netherlands, but it could also be in Australia because most of them will already be there for the IAC. So maybe we can look at some conference hall for the IAC that we can work from, or another location that we could set up MCC, and then you just deploy the system. Takes about a few hours, and you're ready to go.
So that's you will use the same
Yeah.
one. So what weight is that? The system?
So this consists, I think the whole habitat is about 200 kilos, but we put it in ergonomic bags, how we would like to say it, so that then 2 people can carry a 30-kilo bag inside a lava tube, but also can carry it, for example, over a desert.
Okay.
So the only thing that you need is a 4x4, if you go to an extreme location, a 4x4 truck. You load everything in there, you bring it to a location, deploy it, or carry it where you need to go, and it's good.
And would you think also to have some cargo of experiment
Yeah.
contribute to the locally, or also? I mean, we would be very interested to use your facility to do also to put some of our research experiments. So.
And we currently have 2 habitats, but it takes about 2 months for us to build 2 more habitats. Depending, of course, France has holidays in August, so that might be 3 months.
Thank you.
Hello, this is great, and so cool to see Cody. It was awesome. I just had a very quick question. Your mesh network,
Yeah.
you mentioned it's a commercial off-the-shelf system.
Yes.
You know how, and it sounds like you're developing some custom software with that as well. You know, I love that idea. I just want to know, you know, how long did it take to develop, and then what you're continuing to work.
So for the communication system, I think it took about 8 months to develop the software and really to implement it, test it, and get some first feelings of it. And also, of course, we need to make constant iterations. The noise canceling was a big factor because if you buy something commercially off the shelf and that only works for a certain area or a certain space and you want to upgrade it, we basically amplified it. So something that works between 2 people who are riding a motorcycle on just a few hundred meters away from each other, we suddenly had to expand that on a global level so that it can relay and work for somebody who is listening in Japan, while also somebody who is listening in 10 kilometers away from you, while having 4 of those together. It's
And was it, if you don't mind me asking, I hope this isn't too in-depth, was it entirely internet-based, or is it intranet? Or I can ask after we're all done.
Yeah, we can go more into the technical details. The communication system is mainly designed with Niels, our system engineer on that end, who is also the IT guy in our department. But basically it works with a mesh, and then it relays. Like, I'm not sure if you guys ever streamed movies and then you relay it basically to the next person illegally. Sorry. But that similar principle works for it.
And then what is your maximum? Just curiosity.
What?
What is the maximum number of?
I want to test it up to 20 suits, but I need more suits for that. So, but we can maybe do a test. I think right now we have 10 available for comps. So if you guys bring your suit or something else to the IAC and to the fashion show, we can maybe do a comm relay during the show. Just an idea.
Thank you.
Cool. So I just had a quick question about your ultimate goals with the suit fidelity. And are you working towards emulating or replicating the characteristics of the Axiom suit to get the feel of being in a real suit, or are your goals different than that?
I tried to obtain more information from SpaceX, from Axiom, and everybody else, but unfortunately most of that is, of course, IP protected. Right. As well, I'm not a US citizen. We don't have US citizens, unfortunately, working in our team. So we're looking as well for advisors. That's another point. Because we're growing so much, we're looking as well for external advisors with a lot of expertise to really expand that knowledge and to look how we can further improve it. The goal of ICEE.space with this suit right now is just to be a facilitator and a demonstrator. So it's mainly focused on the research needs that are out there, such as sign language. How can we improve that?
I noticed, just a quick add-on, NASA has a program where they've been trying to develop a training suit and validate it against a real suit so that it can provide real results during training, real feedback. Are you familiar with that program?
Yes, and I was working with the NASA suits team on really more the integration of the helmet. But again, you need to be a US citizen. So I was only an add-on researcher, a European researcher, so I'm only allowed to see this amount. And unfortunately, NASA doesn't allow that knowledge to expand yet, as far as I know. But if there would be opportunities, I would be very happy to hear, to see how we can improve that, especially the open source ones.
Yeah, great, thanks.
Thank you so much for the presentation. I really loved it. And I think it's a little bit connected, my question, to what it was asked before. So a couple of friends and I are doing a research on basically analyzing different types of spacesuits. And we will actually be presenting it in IAC in case you would like to come. But my question goes to specifically, what is the process for like co-developing new technologies or spacesuits with other partners? So I am really interested because my team and I, the idea of doing the research and the analysis first on what are the disadvantages, the things that needs to be improved, and some proposals. With this research that we're doing this year, for next year we want to see how we can propose a new design of a spacesuit. So I think my team and I will be really happy to collaborate together. And besides, we have US team members, so maybe it will be beneficial to work together.
Yeah, thank you so much. First of all, for anyone here who's going to the IAC who has a presentation, maybe we can organize them with CHASM that everybody submits their dates that they're presenting, the time and the topic in the chat, or have a form for that. Just see what is possible.
Sure, we can enable that.
Yeah, perfect. And then in terms of the suit process, this is a demonstrator and a facilitator. That means that anybody who wants to do suit research can do it. You get the suit from us, you rent it out, or you do a mission, or you bring it somewhere, you implement your research, and then we can co-write, or you write it yourself, and we just facilitate only. It's really up to the person who wants to do the work.
So I have a question regarding the longer duration EVAs that you're doing. So 8 hours is extremely long. So can you elaborate a bit more about the ergonomics of the suit? I don't know, drinking things or whatever you did to allow for such long EVAs for the astronauts?
Very, very good question. So for CHASM 1 and CHASM 2, the EVAs were about 8 hours. For CHASM 3, of course, it hasn't taken place yet. So we haven't done the 8 hours with the new suit yet in the lava field. But for CHASM 1, when we use the Astroland suits, actually they are open. And in Iceland, we have a lot of flies. So we noticed that having a closed helmet so that flies cannot come into your visor and you don't have to spit them to death is one of the lessons learned that we had to support and provide more into. And as well for the toilet. Big question we always get. We let the Analogue astronauts wear a diaper, basically. Sorry, can you hear me? Yeah. Okay, perfect. So the Analogue astronauts, they wear a diaper, but before they go into the mission and before they start the 8-hour EVA, we take them out on a geology field day. Luckily, Iceland has volcanic eruptions, so we always try to see if we can visit a live active volcanic eruption. We basically let them wear a diaper and train them for 12 hours to see if they can hold it to some extent.
And what about water? Because essentially you're saying they sweat for, I don't know, in 5 minutes you're sweating like crazy. So do you have any water support, a camelback or something?
No, unfortunately not. That would be some of the things to add on. But the problem is with water, it adds weight. And how the more weight you add, the more imbalance you will be at certain points. So you need to compensate. And with water as well, if it comes with the electronics, it can cause some issues as well. Most people are okay with not drinking water for 8 hours if they drank a lot of hours before that, and they will drink it afterwards again. In terms of food, again, we make sure they have a good meal before, the day before. We don't give them any coffee the day before as well, and then we make sure that they have a really good meal afterwards. As well, a lesson learned that we had the first 3 days, we don't plan any massive research or simulated EVAs to be done. We really try to give them as much time and space to recover on that. Okay, hope that answers the question.
Yeah, and I'll follow up with you.
Okay.
I was about to ask something else, but like this water question now has kind of tickled my spidey senses. Have you ever been to desertous environments with the suits, or only to Iceland so far?
Only to Iceland this
Okay,
time. Yeah.
because this is a big red flag that's waving like this. Because and how do you cool the suit? Is there any
Not right now, but we have some research going on that we're testing with Sam Ross, who is sitting over there.
Okay, so if temperature and sweating and heat transfer is not an issue at this moment, then but down the road.
For Saudi Arabia and Mongolia, these are big red flags that we're currently working on. So if there are any master and students who are listening in who want to develop and work on that.
But just to give you an idea, like Space from astronauts prehydrate like crazy. Like they drink lots of water. They actually kind of max out on what the body can absorb before going on EVA, and then depending on the temperature, they will consume. They will consume like up to 2 camelbacks, like attached to the legs during the mission, and all this water just evaporates. It's gone afterwards, so they will not even use either the absorption garments that they're also wearing, like in your simulation. So that's a similar thing. But and also like for me, like as an endurance athlete from time to time, you can drink like up to 20 liters of water in 24 hours and do not need to go to the toilet. So it's like the most important thing to not pass out. So. But yeah, okay, this is now not for Iceland. One question concerning, I read the HoloLens integration and the mesh network. Like, do you have any rough numbers of the bandwidth that you're able to pump through the mesh network? Because like a HoloLens needs kind of high frame rate for you not to get like dizzy. I heard that the US military had some dizzying experience with like AR goggles that were not up to the frame rate that they need to be. Did you do any field tests on that already?
Yes, so we wrote a paper for the ICEE 2 years ago, so that one is published. We also submitted one to Acta Astronautica. Unfortunately, that one got rejected because the N number of participants was only 3 and they want 5. So I recommended to NASA Suits to redo the test and get more funding for that to redevelop. They did not get any motion sickness or have any irritation on that. The only complaint was really the headache because they were wearing it for such a long time. But because they're in a lava tube, they have to move very slowly already because the light needs to really reflect to the HoloLens. That's also why we use yellow gloves, because it's the best color for the HoloLens to detect in the dark, and it reflects, the neon light reflects to it. So they have to move very steady. At some point we were doing kind of a crab dance with the Analogue astronauts just to get things moving. So they don't really rotate their head. They rotate their whole body.
That makes sense. Thank you. And congratulations, of course, to the habitat. It looks beautiful. I can't wait to visit you in Iceland next chance.
And in terms to the water comment, I really would like to see if we can maybe ask OEWF for some advice, or if you want to be interested to develop and look into for Mongolia and Saudi, how we can make sure that it is a safe cost for the analogs.
Yeah, sure. I think the Analogue astronauts themselves would probably volunteer to share information. I don't know whether you want to follow up on that as well. Yeah.
No, just on the design also, because you were mentioning the electronics, and of course this is also an issue for us, so we found ways to put it into the suit without interfering with the electronics in the suit. And I already, at the comment, I could hear the BME saying no go, and that's it for the EVA. So if we tried that, we would not do any EVAs.
Yes.
So,
right now for Saudi and Mongolia, we're not planning any 8-hour EVAs. They would be an hour maybe. Yeah.
Yeah, but so like the simple answer is like just put the center of gravity as low as you can get. Like if the water is below the electronics, then as long as the astronaut is in an upright position, then the water will naturally kind of drown away from your electronics.
Well, if there's a leakage.
Yeah, but still, like I mean, I think I can share that the platypuses are below the PLSS. They're not inside the PLSS, so they're in the suit, but not where the electronics are.
Okay.
So that's a convenient place to put them, I think.
Good. We'd be happy to have a more discussion after as well.
So our last question is
Okay. So I have the last question. Okay. Thank you. Hello, thank you for the presentation. I was just wondering, because nowadays it's such a buzzword, why you talk about head-up display and not augmented reality, because that's kind of what it is. Anyway, my question was more on the keywords that you used with habitat and the spacesuit and ICEE.space and I didn't see the lunar facility. Are you in touch with them because they have developed a spacesuit to simulate operations on the lunar surface? You are talking about the lunar surface. So are you in touch with them? Will you put your habitat on the surface of the moon inside the lunar habitat? Where are you with that?
Yes, we are in contact with them and we're trying to set up a mission with them. So we have submitted our proposal, but they have their opening like in a week or two. So I hope to visit them after because they're very busy right now and then indeed see on that. One thing that we're mainly concerned about the lunar facility is the regolith. Inflatables, regolith, again, not very good combination, and as well the static to it, how much would it damage the structure, but these would be the interesting topics to really look into. Yeah.
Okay. Well, maybe see you there at some point.
And in regards to the heads-up display, mainly they have a CUF checklist, the astronauts that they work with. We fortunately cannot really work with that during an analog mission. I've worked with that in high seas as well. And again, if you fall over, if you lean forward and something happens, it's detrimental. And the HUD also allows, as you saw on Friday during the Polaris Dawn mission, that MCC can see what the astronauts are seeing. So it allows for them to see the procedures very clearly. It allows for waypoints. It allows for navigation. You can even listen to music, watch a movie. There are so many possibilities.
I'm all for it. Don't get me wrong. I really love this idea.
I thought that Spaceship is also, or did something about it in 2021. There was also some development of a heads-up display by someone from the TU Delft.
Yes.
Yeah.
At Spaceship ESC, yes.
Yeah.
Thank you.
Great, thank you.
Fantastic. Thank you again, Charlotte, for this wonderful presentation.